We do have to start chat. Disclaimer, et cetera, not related to county. That was a joke. Sign it, please.
For legitimate legal reasons.
Yeah, for legal reasons, that was a joke.
For legal reasons, I am.
Well, that's on you. That's not a you problem. Sign it. Do it. Is anybody not signed in yet? Sweet. Okay. Pretty much same out since last time. Yeah, still the organizers, if you're interested. For the one that we're running in what, February, early February, something like that. That should be fun. We're starting, we've already started planning a little bit, but we always need more people, need more bodies. Let's see, NCO fall season. I think we're buying the keys for that tonight. That sounds right. It took this long to get here this morning. I'm surprised. Let's see. Dragos MT and APC, same weekend. Absolutely Dragos one, if you want to get involved in that. And then we run Nate every year, so that'll be fun. Let's see, Queen City Con, Blue Version B-Sides. I mentioned last week. It's happening November. It's $50, which is pretty good. That's all the big things I have. Any questions for me before I stop on it? What, Chad?
I forgot to put Codebreaker up there. Sign up for Codebreaker.
That's. Oh, yeah, we are in 22nd place, by the way, for Codebreaker, which that sounds bad, but it's not. I count on teams. I don't remember the exact count. Yeah, let's find the exact count, but 98. Okay, it's not great, but we're in the top 35%, so that's actually okay. What?
Oh, wait, 292, my bad.
Oh, okay, we're good.
Yeah.
Okay, we're good. No, it's very fun. It's collaborative learning, it's free, and it runs until December. So if you do really well, you'll get something. You'll get both the prize and probably a job offer from the NSA. If that is something that interests you.
Both of those are very closely connected.
Yeah, very closely connected. I don't know. It's also just like super interesting challenges, more so than like policy tests. I would argue they're more real.
Yes.
I mean, yeah, given they're loosely based on things that are from actual missions.
Potential hot air balloon that may or may not have been above the US.
Unironically, that's
Oh, it's splashed down in the
It's an
ocean.
unmanned civilian aircraft.
unmanned civilian aircraft.
It's a weather balloon, guys.
Yeah. But 22 out of 292 is pretty good, especially because there's some people that have already finished the breaker, which I have no fucking idea how. I guess they just work at NSA, I don't know. So that's cool. Anything else? Before you leave and shut up? That's all.
Okay, so news. We kind of talked about this last meeting, like while I was doing this, the whole black tech activity. I think Seth brought it up. I read a little bit into it. Basically, like black tech was like modifying router firmware, which is kind of scary. Pretty cool stuff. I saw this. I think it was earlier this week. The SEC chair announced a plan to restore net neutrality, which. And like they removed it like in 2015 and kind of just like was and they're now bringing it back. So who knows? We'll see what will come out with that. The Sony data breach was confirmed. I think it was around 6,000 customer data. 6,000 individual customer data was released. It came from the Root vulnerability, which is going around like crazy right now, so it's kind of their own fault for that. There's a company called Johnson Controls, which is a building automation company. They suffered a ransomware attack, encrypted ESXi servers, which are, I forget exactly what they're doing.
It's VMware's.
That's what took 27 terabytes of data. So they encrypted 27 terabytes of data, and it's $51 million ransom. That's pretty cool. I forget what security researcher, but a security researcher figured out that you can trick Microsoft's AI Bing chat to serve malicious ads, which is pretty cool. If you don't know what malicious ads are, so the context for that is like, I can't say that. Certain companies will have adversaries that target them and will kind of spoof a page that looks like the actual company to like steal stuff. Probably the biggest thing that happened was the vulnerability from Chrome. So there's kind of a two-step development of that. So the first vulnerability that came out was that CVE 2023-4863, which was just specific to Chrome. Later, once more research went into it, there was another one was tagged as 5129, and that is kind of the overarching vulnerability for the entire thing. It is a vulnerability in the web key library, which impacts browsers outside of just Chrome. So Android browsers, Firefox, Edge, Safari, etc. So that's pretty cool. VS Code. And VS Code apparently. So, and basically what the vulnerability is attacker able to execute out of raw memory writes just using HTML codes. So, fantastic. The NSA is establishing an AI security center. It is I forget their exact wording, but it was pretty much to make sure that the AI does not do anything it's not supposed to do. So, yeah. From Russia, Ukraine, there's two things that have to happen. So Ukraine activists are targeting Russian airline systems. So that's interesting, and I thought it was kind of funny. The British Royal Family's website was a DDoS by Killnet, and they are a Russian activist group, and Killnet themselves claimed it was an attack on pedophiles. So that's their close not mine. Oh yes, anyone else have any news that they?
Well, I mean.
I did have a question.
Okay.
What specifically, on the airline side, what specifically they're trying to enter? If not,
I can cover that. I kind of just like take notes and they all stuff I see, but piques my interest, like do more notes. That was my interest.
How old is the movie vulnerability? Don't get worried about it.
I think June.
This June?
Yes. So what? 4 months and same exact vulnerability, hundreds of companies compromised, and I can't remember if Sony's was in June. I think Sony's actually might have been in June and just now coming out. But yeah, there's people still getting into it, so that's great. Yes.
So they hit the actual like working scheduling system.
That's
what it was. Racia and Aeroflot, which are the two biggest airlines in the country.
Yeah.
Just for shits and giggles.
Anything else this week? No. You were here last week, Chad did a cool presentation on cloning and binary exploitation. So if you weren't here, that is up on our YouTube channel. So I'm going to be talking today about containers and how to break them. So how many of you guys have heard of containers? Yeah. Okay. How many of you guys have heard of VMs, virtual machines? Okay, so the best way to explain it, they're very similar for different purposes. When kind of touch those differences a bit, because that kind of helps explain how you break a. So, very high level, containers is software that is bundled up to be as lightweight as possible. So when you have a virtual machine, right, you're dealing with an entire operating system. Containers kind of strip away the pieces that you don't need to only run something specific. It can be as specific as like a Python script or an executable. You can technically run a lightweight Ubuntu image on the containers. It's a little bit more not as lightweight, obviously, but you can do it. I use containers because they're easy to move around software applications through different environments. So, you know, when you write a program on your computer, there's certain dependencies that go with that. The larger the program, the more integrated it is, the more you have to work with. Containers allow you to put all those dependencies inside the package, and you can move the dependencies and the code together. That way it can run on anything. So it also kind of splits up the roles, right? So developers can focus only on the application itself, so the code that is running in the container, and then operation and infrastructure teams can focus on the actual infrastructure, which is the resources that host the containers to run. So it kind of divvies up the responsibility as well to increase productivity. There's these things called managed platforms, which is basically just ways to maintain and just handle containers. So that some of them bigger ones are Docker, Kubernetes, and Containerd. We talk about Docker in this one. Do you have any questions about that over high level? So this is what I was talking about with containers versus virtual machines. So as you see on the left is the virtual machine, and right is container. The biggest difference is that and I'm going to highlight this for a reason, the virtual machines have their own kernel, right? So kernel is like the underlying code that I do not too technical know what it does, but it's the underlying code that helps the operating system run. Virtual machines have their own. Containers use the host kernel. So they rely on the container manager to kind of use those resources as needed, which is important. Yes.
Isn't there also like some, I'm not super familiar with it, but there's like hardware shit for VMs, and then containers is like, it's more on the software side. Because like with Intel, there's like VTX or whatever, or VTD.
I don't know if I'm going to answer your question, but are you talking about how like you can run VMs like straight on hardware?
Like there's some sort of, I guess the CPU itself has some accelerator in there that uses it to like kind of split the virtual machines apart to make it more secure.
Yeah, you gotta like enable something in the files. Like enable virtualization.
Yeah. So the hypervisor so the hypervisor for the VM kind of works to kind of keep the VM separated as you need away from the host. The container manager doesn't really separate it. It does in a sense, but like if the container is privileged, which I was going to a bit, you can kind of get through that little barrier there. All right, so Docker. So Docker has these things called images, which basically it's a file used to execute code inside a Docker container. The best way to think about it is it's a set of instructions that actually build out the Docker container itself. It's like a template. So this template or set of instructions are usually used on Docker files, which are going to it's going to be different, but it looks fairly familiar to stuff you've seen before. And that is just like a very easy rudimentary way to like actually build an image. So this is what an example of Docker file is. This is actually the Docker file for the thing I'm going to be doing today. The top line of the Docker file says that from Ubuntu latest. That is actually a pre-built image from Docker itself, the Ubuntu image. So that from is kind of saying, I want to use this image as a baseline. From there are a set of instructions that really customize and compare to what you want it to do. So I'll skip over the two R's, go to those runs. So you see that says run app update. That is literally running the command app update inside that Ubuntu container. Or sorry, it is telling the image to, when it builds itself, to run that command inside. Same thing with the one below it. Copy is copying so it's copy dot and then the slash app, so that dot is the, just is referencing to copy the entire folder contents that the Docker file itself is in. So any files that are in with the Docker file, be copied into the image in the directory slash app slash. The work directory is just saying, it's then saying, basically like CD, or change the directory into that slash app. We'll skip the run SCD, that's just doing something for the exploitation. And then we're running a permission scan there. And an entry point is where is the last step in building an image. And when you run an image to make it a container, I guess, that is what command is going to be run. So in this case, when I build the image, it's going to build out the image, grab the image, then going to run the image in a container. As soon as I run that image in a container, it's going to execute that script, which is part of the script that got copied in when I copied everything to the top. That might not make any sense because I'm not showing you what I'm actually doing. Okay. So, the actual container. So depending on how the image was built, a container could literally do anything. You can open a shell and a lightweight Linux image, so like that Ubuntu thing I was talking about earlier, you can literally run a specific Docker command that will give you kernel access inside that container at that moment. Don't often do that, but you can do it. You can open a Python script shell, so where instead of having the first line be from Ubuntu, you can really have it be from Python, and you're just using Python. You can directly execute the program, which is what I said, or you can also host something in application. So one of the largest use cases for Docker is in the enterprise world, and they use it to like just manage a bunch of different applications, backend stuff for various softwares that can really do never like anything that you guys probably exists. Okay, so anybody have any questions on Docker containers, anything like that? And I kind of flew through that. So how do you exploit Docker containers? Does not have to be Docker specifically, but this example is Docker. So, little cube on the left, top left there, that is simulating the stack for the containers, right? So it's an application runtime system, container manager, it goes through the exact same as I showed in the diagram with the VM container. So the application, which is the code, is executing that kernel insert script that I was talking about. What that kernel insert script does, I'll go into details later, is essentially going to be installing a kernel module to the host. Now, this is kind of where you get the difference with the
So people that might not know what it's for.
essentially a kernel module is just like, it's a piece of the kernel that you can add, I don't know what the definition is. Yeah, it's an add-on. It's an add-on to the kernel that allows you to do some different things. Yeah.
So wait, if you're running a Docker container, it just lets you like say whatever modules in the kernel you want.
Yes, no. So this exploitation relies on two things. A, the Docker container has to be being run on Linux, server, box, whatever, because it relies on those kernels to be used. And the other is that when the Docker container is ran, it must be privileged or have a certain privilege that specifies it is allowed to add or remove kernels with the host. And that's kind of where you get that difference between the VM and the Docker and the container, because VM has its own kernel. So only referencing that kernel, never to the host kernel. The containers, it uses the host kernels, therefore we can modify it and do some stuff. So this kernel, let's say, it could do anything you want it to. In this case, it is going to be sending out an external connection to a remote server with the IP 122.122.122. the way the script is set up is that it will actually give remote access to the host at root, because you're running it at the kernel level. So I know that's very hard to understand what it does now. I'm running through this entire flow. Cool thing is you can run the container, you can kill the container, you can do whatever you want with the container. That module's still in there, and you will still have access to it, even if the container is not running, which is very, very cool. Okay. Let's see if this works. Oh, do I have to?
Yes, which is the issue.
Okay, so let's look at what the actual code for this looks like. So the Docker file, like I said, just the same Docker file that I had before. It is executing this script called kernel insert .sh. What this script does is it is installing the Linux headers for the host operating system. So for those of you that don't know, I'll try to get a loose definition of what Linux headers are. It deals with how when you compile code and the rest of run on the right system. This is kind of where I get the area that I don't want to tonight. So this is here just getting stuff ready for running the code, and then this command right here is checking to see if a module with this name already exists. Ideally, if you're running this in a real life thing, you would name the module something not a little less like more obscure than the first shell. Yeah, don't name this. It would be like something like, I don't know. I get it. Module already exists. You like change one character on it or something like that. And then if it does exist, then you remove it with that rmod command, and then you're going to insert that module. So you insert it and then you remove it. So then, like I said earlier, once you install it, it instantly removes itself. But by that point, it's too late. That connection's already been made and already exists. This is the code for that module. If you hide my it looks here. Essentially, what this is the key part right here. Line 9. This is very basic level. Like you could Google search how to do this, and I'll tell you how to do it. It's sending a bash command to a IP and port number, which you can specify either the container or by default it just does. So, what does it actually look like in practice? So on the left is going to be the we'll say developer terminal, right? So this is where I'm going to be building and executing a container. On the right is going to be the quote unquote remote server in this case.
So you're running a container as root.
Yes.
That's why.
You don't have to run this root. Yeah. Whether or not you're root or not root does not matter. It's a flag you
Oh,
put.
because the Docker container runs.
Yes, Docker container by default will run this root when you install it. So I'm on the bad guy machine on the right. I'm just going to open a port with Netcat. I'm listening on port 44. So this is going to listen for any sort of traffic that comes through port 44. Also, demonstration sake, I'm going to start a. So we'll wait till that goes over. So I have pulled down that directory on GitHub. I was telling you about that page. So this is all the files that you need. In order to build the container first, you're going to unbuild, Docker build, dash T image. So the image is, so after dash T, you give the name and a tag. The tag is how you specify different versions of an image. So we'll say, and then you add the path to the doc file afterwards, which is just the correct directory, which is doc, and it should build. So I did this earlier, so this is all this is the cached results of one, which is why it was fast. Otherwise, it'd have to individually run through all of those steps in that Docker file, just from start to finish, to actually build up that image. And you would see it run those app installs, app update output. So that could take a while, which is why I cached it for you. You can actually see what images you have already. So as you see, I have an image with that tag demo, an image with the tag latest, which I did a while ago, and I have an image on Bluetooth, which because I use that from in the start of the image, it pulled that image out. So now we have the image done. Now we're going to run a container. So here's the. So you might think this is dumb, but it's common practice in not the industry, but in like corporate environments that you run containers or just do things with privileges you don't need because that makes stuff work better. It does, but that causes problems. So while me typing that looks like an obvious thing, and oh, you shouldn't do that, you would be shocked to know how many containers and stuff is privileged and shouldn't be there. It's you can either do it with dash privilege or you can add a capability to it called sys _module, but that's incorporated with privilege, and it's more common just for some slack on a privilege tag. So I saw a write-up on some guy. He found like a publicly it was a Docker like workshop site. I think you might know. Kind of like learn how to use containers, and the container that has you in the desk was Wrangler privileged, and he was able to do what I'm about to do onto that. Like already running existing container, which is really funny and cool to see. So yeah. So now I'm going to specify that image name that I built. So in this case, we'll do that demo. So when I run this, what I'm essentially saying is execute that shell script that is already in that image, that kernel dash insert, and it's going to check to see if that insert exists. If it does, remove it, actually might, and then it's going to install it and it's going to move it again. Pay attention to the screen on the right. So it's going to run that command, it's going to look for the Linux headers. It's going to install them. So this is that output you'd see if the other part wasn't cached. If you notice on the side on the right, which is emulating the attacker's screen, it now has root access to the machine. So just like that, and I mean, it's literally that's the entire system right there. This is the host. So you don't even get access to the container. You don't get access to the container. You don't turn off the container. This is the actual host. So if you can picture it like this is, I know it's hard to do because it's like the same computer, but it's essentially like this could be some random IP address in the middle of nowhere, and you can tell the best use case for this in that case would be like you build an image with your IP address and port you're listening on, and you have some pre-existing way to hijack some sort of developmental process that a company may have. So I'll say that. Because there's a lot of different, like, it's really hard to explain what, like, development and, like, DevOps looks like in any company that is, like, just no class to teach that. It's very, very, like, complicated, it doesn't need to be, and there's some loopholes in there. And this is kind of bank on the fact that you find a loophole. So, I pulled that Wireshark actually just to show you this. So you can actually, because this is all in the clear text, which, again, you can actually see the commands that are sent back and forth, right? So, okay.
So if the victim restarts the system, will that kernel module still be in there?
It could be. So, the version I have of this, I'm removing it because in this scenario, I'm saying I'm going to do the damage once I get it. Which, if you're quick about it, like once it's in, it's in. I actually did experiment with that. I was doing this. You'd have to rerun that module, I think. I honestly am not too sure. I don't think I actually tested the use case of restarting, because I think that kind of goes into stuff I am not too comfortable about. I'm pretty sure you could like set that module to be incorporated and boot it up. Do that in this case, but if you did do that, then yeah, I think you're right with it. It'd be kind of a free kid type. But there's better ways to do that than this, I think. So so because I was listening on that loopback address, which is just 127.01, I was able to capture the entire communication string as it happens. So while this is very like quick and dirty, and like are not very like stupid if someone was actually doing this. So you have to find some way to either encrypt that connection or obfuscate it in some sort of way where it's not just in the plain text. In a real life scenario, there's probably going to be some sort of protection on this just because of what it does. Like this just set off several red flags. Keyword there is should. It doesn't all the time, which might be confusing. And again, that comes into place of like containers and cloud and whatnot is still very, very fresh in many companies' minds because like while they have the tools in place, they don't know how to secure it, nor people secure it. So that's kind of another thing that goes with this. That's still kind of new in terms of security. That's kind of all I had. Does anybody want me to run through any of that slow or explain something a bit better? What? I will say Docker for like, so I did this over my past co-op. I don't know a single thing about Docker or like kernel stuff at all. Docker containerization in general is a very good skill to have, especially if you're going down the route of IT and IT cyber because like it's so good. I think cold work with them all on it. Not Docker. Yeah. Or we're looking to do some sort of containerization in the lab too. So I think, right? Yeah. I was confused. Run that. Sort of. Yes. Yes and no.
I mean,
We work.
yeah, but also, yeah.
Okay.
So it's everything. You might not know, but it's a lot. It's all good. There are several different ways to do it. Break down containers, not just like that. That's just kind of one that I for it. So. Like it, sure. Yeah, cool.